I just wanted to go ahead and just film showing you how to use the idea of this handout um, instead of doing it live, because I know that for some people it might be easier to be able to pause or rewatch. And so we're trying to make sure that we can convert from decimal to binary. So these are base 10 numbers. And the procedure that I use, which is effectively the same one on the handout, is that you think about place value in binary, which is powers of 2, and it doubles each time. This one's almost large enough. If we go one more, it's way too big. So that's a oops. And then from there, we're just going to think of these as like the tiny electric switches, and we're going to switch on the ones we need. So we're starting at 39, and we X this one out. So we definitely need 32. So we'll flip 32 on, and we'll subtract 32 from 39, and that will leave 7. And that means that we can't include 16. 16 would be way more than 7, so we leave that switch off. In fact, we also leave the 8 switch off because 8's more than 7. But 4 is less than 7, so we switch that to being a 1, and we come down here and we subtract 4, and that leaves 3. And then 2 we'll switch on and subtract off, and that leaves 1. And if we switch on 1, we'll subtract 1. And that's a 0. So this will always be 0 at the end. And this would be the binary form of 39. 32 plus 4 plus 2 plus 1. Some students think this is the harder direction. I think it's easier to just turn the ones into those numbers and then add them up. And I get that. I mean, subtraction is a little, like thinking backwards is always harder, and subtraction is thinking backwards for addition. Let's go to a little bigger number, 572. So again, 1, 2, 4, 8, 16. Power binary is that it's doubling each time, which is a question that some of you all had trouble with on the check for understanding. And so while these do start off small compared to decimal, they get rather big rather fast. All right, 512 is almost certainly close enough to 572. Double this another time would be 1024, which is just way too big. I go to the 572, and I'm going to flip the switch and turn on 512 and subtract, and this is 60, which means that the 256, the 128, and the 64 are all too big. But the 32 I can flip on. And I'll subtract 32, and this, if it were 60 minus 30, it'd be 30, so it's 28. So I can flip the 16 on, subtract 16, that would leave 12. So I can flip the 8 on and subtract 8, that would leave 4. I'll flip the 4 on, subtract 4, get 0, which means that anything to the right of that, I'm out of room, I'm out of numbers. I just got to put my placeholder zeros in. When you write this or this number in binary, you might want to start on the right and write it in like your byte form where you kind of do 2 groups of 4. So the divider's right here. So this one you would actually have 2 leading zeros. You don't have to write it that way. You could just write 1 0 0 1 1 1. Again, the divider would be right here and right here. And so if you were writing this one in byte form, you would have 0 0 1 1 1 1 0 0, And then you would actually have part of this number was large enough that it went over into the next one. So maybe I choose not to write leading zeros this time just because I'm kind of out of space. Well, that was kind of supposed to be a quick one to help you think about going the other direction, starting with just a random number in base 10 and how to quickly convert it using repeated subtraction of your powers of 2. And it's just a matter of quickly realizing how you should start as you go to whatever would be the biggest power of 2 that's less than the number you're trying to convert to binary. All right. Thank you for your time. I hope that was helpful.